name is Jason Paulus, and I am a senior mechanical engineering student and also leader of the 2021 Cedarville University Solar Boat team. I'm super thankful to work with all of the talented and gifted individuals that we had on the team this year, and I'm also very thankful to our advisors, Dr. Dewhurst and Dr. Brown. In preparation for the 2021 Solar Splash competition, we've been working very hard in a lot of different areas. First, we combined the drivetrains for the sprint and endurance competitions into a single universal drivetrain, which will help us eliminate about 100 pounds from our boat. We also acquired new motors, and we're designing new propellers in order to get as much power out of the drive system as possible. We've been doing a lot of research into the health of our batteries, and we've been developing a program that will help us to drain every bit of energy out of the battery right by the end of the race. And we also did a complete overhaul of the electronic system on the boat, replacing it with an entirely Simulink and MATLAB-based data acquisition and control system. Ultimately, we hope to be faster and more efficient than ever. We're very proud of the work we've done, and we're very excited for competition this year.
Hello, my name is Jonathan, and I was in charge of building a new drivetrain for this year's team. So last year they worked on making a design to combine our two separate drivetrains for sprint and endurance into one in order to save weight. They tried to do this in previous years, but were unable to find a motor controller combination that would work really well. But last year they were able to find the Hawk motors and in-motion controllers, which they believed would work for the new drivetrain. So I manufactured all of this, and it allows us to switch between the sprint and endurance configurations by undoing this clamp collar and sliding the whole assembly up and down. I have two different size fairings. This is for the sprint configuration, and then it drops down and you put the larger fairing in and the larger propeller in. Basically just allows for clearance of different propeller sizes relative to the bottom of the boat. And also this tiller arm gets flipped over to clear the solar panels for the endurance race. We've done some preliminary testing to make sure this functions, but we have not yet tested it out on the water, and we're looking forward to seeing what it can do.
Hi, I'm Kaylin, and this year my responsibilities have been to design, test, and manufacture propellers. In terms of design, I've created a propeller to be used with our Hawk 40 motors that we just acquired this year. The propeller that I created was to be used in our endurance race of the Solar Splash competition. We are waiting for motor testing data to confirm that this is the most efficient design for our boat.
I'm Zach LaPearl, and I've been responsible for the motors and motor controllers for the Cedarville Solar Boat team. And part of the motor controller process has been creating a new dash to talk with our motor controller. So here you can see our previous dash, which had a liftoff cover. There's a bunch of terminal strips behind there, and this is one of our internal computers, and then this was our display screen that we used. Now, with the new dash design, we replaced the display screen called the VCAN with a tablet, which runs all of our recording software on it. And then it also hinges forward to allow for easier access to the back of the switches, making wiring a lot easier. But when we tested this design in the boat, we found it was a little too round and needed to be shortened up a bit. So we moved on to this new design, which incorporated it as all one dash. There's no folding flaps anymore. But one of the new features with our motor controller was the full stop, which is a button which pressed once, it'll give the same speed in the opposite direction with the prop to act as a reverse brake. And on the second press, it'll disable the drive because it's supposed to be used as an emergency stop feature. But you can also see the dash hinges, and it's a lot smaller on the inside, but we're trying to reduce space and reduce wiring anyways. And everything can fit in here. So this is the design we went with, and this is the almost finished product here. As it'll eventually hinge and open up, just like the other dash. And that's all I have for the dashes.
Hi, my name is Katie Linville, and I'm one of the senior electrical engineers on the Solar Boat team this year. I was in charge of working on the software systems for the boat, so that included working on our CAN bus model and the user interface. For our CAN bus, we wanted to make sure that we were able to send and receive signals, as well as send them to the user interface and log all of our data for further analysis. For the user interface this year, we were going to develop a new tablet app. So this way we could have a tablet on our boat that would also show our testing data, all of our testing screens, as well as race modes. So for the user interface, I developed it in MATLAB App Designer, and it links really well with our CAM model. Here's the new user interface that I developed this year. It's a 3-panel GUI. Along the top panel in the overview section is our 3 systems that we're working with this year. You can see the solar splash button will be for our solar splash boat. Under the selection panel will be where all of the specific testing screens and race mode will be at for us. And in the main information will be where our data tables are.
Hello, my name is Kelly Coleman and I'm a senior in electrical engineering. My focus of this project is on the CAN communication system.
CAN stands for Controller Area Network and is a communication protocol that sends, filters, and receives all the signals on the boat. These signals are controlled by hardware called CAN adapters. Our CAN adapters are comprised of an Arduino Nano MCP2515 controller and a custom PCB with through holes for our filter components. These adapters are connected to a bus and the signals are sent using the differential of the 2 CAN wires. This allows us to send digital signals such as switches, e-stops, forward and reverse, as well as analog signals such as voltages, currents, and speeds. We can use these signals to control parts of the boat such as actuators and pumps, as well as display data to our interface. This is a simplified diagram of our CAN bus where inputs are tied to the adapters and put on the bus. These are then used to communicate with the entire system, perform tasks, and display data on our tablet.
So my name is Daniel Urban, and right now I want to walk you through our test setup for how we test our batteries. It's important to be able to test our batteries because we want to know how much energy we have in our batteries from a full charge, because that kind of gives us an idea of how fast we can go during the race. So here, the first step to testing our batteries, we have to use what's called our electronic load bank, which is basically just a huge heat sink and has a series of transistors, potentiometers, that allow us to take a battery, which we have here, I have it hooked up, and it allows us to, using this potentiometer knob, draw a specified amount of current that we can adjust. We can go up to about 150 amps draining our batteries with this electronic load bank. Now how we record that data, we use what's called our data acquisition box. So we can plug in our data acquisition box into the load bank, which has a current transducer. It can capture the voltage. It gets plugged into our DAC box, which right now I have it set up to, it says solar testing, it's really battery testing. It shows our supply voltage, the battery voltage is at about 12.8 volts, and then the LEM current is how much current we're actually drawing out of our batteries. So if I want to record data, I could just plug in a flash drive, run our test, it'll record it, I could take it out, and that effectively gives us an Excel spreadsheet of our data. The data is important because we can use that in our energy management system, which takes into account the battery charge as well as other external racing factors, and it can calculate how fast we can actually go during the race. So that is how we do our battery testing here.